For years, we've searched for Earth-like planets, hoping to find another, us. But what if the more pressing question isn't about finding life, but about the very structure of planetary systems themselves? Get ready to explore why our solar system might be an incredibly rare gem in the cosmic ocean, forcing us to rethink how planets form across the universe. For most of our history, this has been our model for the universe, a neat, orderly family of worlds, small, rocky planets on the inside, giant, gassy planets on the outside, all moving in stable, predictable, nearly circular orbits. We assumed this was the norm, the standard blueprint for a solar system. But as we began to look out into the infinite crowd of other star systems, we discovered a shocking truth. Our cosmic home is weird, very weird. The era of exoplanet discovery, spearheaded by missions like Kepler, didn't just find other worlds. It shattered our expectations. Instead of finding copies of our solar system, we found a cosmic zoo of bizarre configurations that challenged everything we thought we knew. We found hot Jupiters, gas giants larger than our own, orbiting so close to their stars that their years last only a few days, their atmospheres boiling away into space. We found planets on wildly eccentric orbits, swinging through their systems like cosmic wrecking balls. We discovered that the most common types of planets in the galaxy might be ones our solar system doesn't even have: super-Earths, rocky worlds much larger than our own, and mini-Neptunes, planets caught somewhere between a terrestrial world and a gas giant. The neat separation of rocky and gassy worlds we see here seems to be the exception, not the rule. So how do we compare? The vast majority of systems we've found are dramatically different. Our planets move on a flat plane, like marbles on a plate. Many other systems have planets with orbits that are tilted and misaligned. Our system has a robust asteroid belt and a distant Kuiper belt, neatly separated. This clear zoning is rare. So why are we so different? One leading theory is the Grand Tack. It suggests that in the early days of our solar system, Jupiter migrated inwards, clearing out a vast amount of material that could have formed other super-Earths. It was only the gravitational pull of Saturn that tacked Jupiter back to its current orbit, saving the inner planets. Our solar system's architecture may have been shaped by a lucky, chaotic dance between our two largest giants. This brings us to the rare Earth hypothesis. This idea goes beyond just our system's structure and delves into the confluence of conditions that make complex life possible. Our lonely inner solar system, cleared out by Jupiter, might be essential. Jupiter itself acts as a cosmic bodyguard, deflecting comets that would otherwise bombard Earth. Our unusually large moon stabilizes our planet's tilt, giving us predictable seasons instead of wild climate swings. Each of these features is a rarity. When you combine the rarity of our system's architecture with the specific conditions needed for Earth's habitability, a profound question emerges. Is our solar system's anomaly not just an anomaly, but a prerequisite for intelligent life? It forces us to consider a chilling thought. Perhaps the normal planetary systems out there are actually far too chaotic and violent to ever allow life to get a foothold. So what does this all mean for the search for another, us? It means we might need to refine our search. Instead of just looking for planets in the Goldilocks zone, we may need to look for systems that share our strange, stable architecture. Missions like the James Webb Space Telescope are doing just that, not just finding planets, but characterizing their systems, looking for the quiet, orderly neighborhoods that might be the true cradles of life. Ultimately, the discovery that we might be a rare anomaly is both humbling and extraordinary. It makes our cosmic home feel even more precious, a fragile exception in a universe of cosmic storms. It doesn't mean we're alone, but it does suggest that homes like ours might be few and far between. The search continues, not just for other worlds, but for the fundamental rules that decide whether a solar system becomes a chaotic wasteland or a quiet, stable haven for life. Thank you for watching.